Okay, here's our topic, enthalpy and Hess's law. And Hess's law has to do with when I manipulate equations, what happens to the reaction enthalpy. Here's our objective. And you could think of that when I change the equation, what happens to my enthalpy? Another way to think of it is sometimes reactions have steps. And when I know the enthalpy of my steps, what's my overall enthalpy? Hess's law has three uh, changes and what their effect on the enthalpy of the reaction. The first being if the reaction has several steps, or rather the overall reaction is the sum of several steps. Then the enthalpy of the reaction is just the sum of the enthalpies of those steps. Now, if I reverse the reaction, the enthalpy is going to keep the same the same magnitude, but it's going to change positive or negative. So if it's positive one way, it's negative the other way, but it's the same number. And often we're going to have to multiply reactions or reduce them by some factor, and we're just going to do the same thing till enthalpy. All right, so this is in a sense, if I change this equation, what happens to enthalpy, and that's Hess's law. All right, I have an example that I'd like to go over, and this example comes from a website that I'm going to link in the description of the video, so you can see it written out like there. Sorry, you can see it written there. And here's our equation. Here are our available equations. There's three of them. And you'll see that none of this adds up. Sorry, not none of it, but this doesn't, if I were to add these, I wouldn't get this. All right, because I've got 2 here and I've got a 2 there. So I'm going to have to manipulate these equations. The way that I'm going to choose to do this is I'm going to just figure out how do I manipulate these equations to get what I want, and then go back and deal with enthalpy. All right, so first thing I'm going to do is I see here I've got 1 molecule, and in this first equation I've got 2, but also that this is a product, this isn't a reactant. So how do I take care of that? I'm going to flip reaction 1. All right, and it becomes this. Now, the next thing I notice, this is a 2 and this is a 1. So I'm going to have to reduce this thing by 2. And it becomes this. I divide every coefficient by 2 and it becomes this. Now, the next thing I see or I'm going to deal with is I deal with this carbon solid, and here it's here. And I notice there's a 2 in the reaction I want and a 1 here. So I'm going to need to double this equation. So I double it and then I'm going to add it. Now, at this point, I notice that I've got 2 carbon dioxide and 2 carbon dioxide. These things will cancel out. And I've got 2 and 2.5, that'll also cancel down a little bit, and I'm left with this. The last thing I need to look at, I need to add this hydrogen. There they are. It's in the third equation. However, this is 2 and that's 1. So I have to reduce this by a factor of 2 and then add it. Here's the equation, all right? And when I reduce it, I divide everything by 2 and I get that. And then before I add it, I'm just going to cancel out like terms. This one and this one are going to cancel, and my waters are going to cancel. And I'm left with what I wanted, all right? So now I know my steps, how I do it. And how do I get to my enthalpy? Well, here are my equations, and here's what I did to them. So I flipped 1 and I reduced it by 2. So what does that mean in terms of my overall enthalpy? That means it's going to be this factor times by negative 1/2. And the second one I doubled, so this would be twice times that. This one I cut in half, so it would be just half that. I'd add half of that. I'm going to plug in my numbers. All right, multiply them out and then add them up, and that becomes my overall enthalpy. And it should be kilojoules per mole. All right, enthalpy of a reaction would be in kilojoules per mole. And that's how I do it. All right, hope that's been helpful, and let me know what I can do to help you. All right, bye.